Yeah, we're moving on to derive the variance of a negative binomial distribution. As we found earlier, the mean is equals to r into 1 minus p out of p. And the mean is our expectation of x. And we know that our variance is our expectation of x squared minus our mean squared, which is also equal to the expectation of x minus expectation into x minus expectation of x squared. So we have our mean as we found here, but we do not have our expectation of x squared. So we're going to find a formula that is going to help us find our expectation of x squared, which is, we're going to get it from expectation of x into x minus 1, which is equal to x squared minus x, which is equal to x squared minus expectation of x. So we're going to make our expectation of x squared the subject. Making it the subject, we're going to get expectation of x into x minus 1 plus our mean. So we're going to put this expectation of x squared back into our formula. We're going to substitute it, but we're going to replace it with this new formula that we've gotten, which brings us to this step of this new formula that we're going to be using. When we look at this, we have this, and we also have this, because this is the mean, which we already have here, and this is the mean squared. So we have this, but we do not have this. So we are going to find this. And we know that expectation requires us to find the summation. So when we x into x minus 1 times our PMF, as we recall, is the function for this probability. So we're going to pick out this combinatorial sector of our function, and then we're going to expand it. This times, we're now expanding our combinatorial section of our equation. Then we're going to, we remember our definition of x factorial as x into x minus 1, x minus 2 factorial. And the definition of r into r factorial is going to be r plus 1, r minus 1 factorial. But we want r minus 1. So we're going to make r minus 1 factorial the subject, and get r plus 1 factorial out of r into r plus 1. We're going to use this, and then we're going to substitute what we've gotten here into our combinatorial segment of our equation, which is going to be x into x minus 1, r plus x minus 1, out of our r factorial is r plus 1 factorial out of r into r plus 1. And our x is going to be x. Our x factorial is going to be x into x minus 1, x minus 2 factorial. Yes? And just by looking at this, we can see that this cancels with this. So when we simplify this, we get r into r plus 1, r plus x minus 1 factorial out of r plus 1 factorial into x minus 2 factorial, which brings us to this step. So when we look at this form, we're going to notice that it can be written in a combinatorial form, which takes us down to, remember, what we've been doing here is finding the expectation, this expectation of x into x minus 1. So we have to bring it and replace this into our equation, since we've been working on this combinatorial segment. So when we replace this, we're going to come down to this. So when we see how we're moving, we're going to see that we need to make our function similar to our PMF, which is 1, so that it can cancel, so that we can remain with the formula we've been working towards. So again, we're going to change variables. Changing variables, we're going to let y, our new variables are going to be y and q. So we're going to let y be equal to x plus 2 and q equal to r minus 2. We are going to write everything, all our old variables, in terms of our new variables, like we did when we were finding our mean. So we're going to make x the subject, this is y minus 2, and we're going to make r the subject, q plus 2. So we're going to change each and every variable here and make it the way into our new variables. So we're going to take out the r into r plus 1, since it's not affected. We're going to bring it outside the function. Then we're going to substitute our old variables. We'll work out and substitute our old variables, which will bring us down to this. And we have a situation here. We have to expand our p. We're going to expand p q minus 2, which gives us p q and p negative 2. We're also going to expand this section and say 1 minus p y 1 minus p squared. So we're going to, which brings us down to, remember, this p is going to be affected, but so we leave it inside, but this p is not affected, so we bring it outside. This section is going to be affected by this variable, but this is not going to be affected, so we bring it outside, which brings us down to this. When we bring out this p, it comes down since it's a negative power, and when we bring this one out, it comes here. We're still working with this function, so we have to bring in the summation, but since we changed variable, we changed limits. We're going to work from y from 0 to infinity with our new variables. Now when we look at this section, this is similar to our PMF, even though we have different variables. So this is going to be equal to 1. And when we multiply 1 times this, it's going to remain like this. But this is not what we are looking for. So remember, our variance is our expectation of x squared minus, our variance is our expectation of x into x minus 1 plus our mean minus our mean squared. So we are going to, since we have this, and now we've found this, which is what we got here, we're going to substitute into our formula, where we're going to put what we got for this here. Remember, our mean is r into 1 minus p out of p, and we square it. So here we are going to work out, follow the steps systematically, and we're going to find out that this, our numerator, is going to equal to 1. So 1 is going to equal to 1. So 1 times this it remains, and P times P is P squared, and our variance and the formula for our variance has been derived. Thank you so much.